Okay, let's get going since it's 5 after. Maybe people will join in a bit. Welcome, Alvaro. So anyone want to give updates on what they were able to get done? Welcome, Raquel. Just getting started.
Hey, guys.
Hi. So anybody want to give an update on whatever progress they were able to make last week? Steve, you want to go first?
Yeah, like following up on the document that you'd produced, I sort of like looked through that and saw that it looked like a lot of people who were sort of finishing high up in the competition, they were all using like Catalyst, in addition to the segmentation library and other bits and pieces. So I decided to go off and like take a look at that and try that. So pretty much during the week I've been teaching myself Catalyst and like looking at some tutorials and some people's demos on that and stuff.
So can you give us a quick update of what it is?
Basically, it is like another library that sort of sits on top of PyTorch. So like it'd be very similar to FastAI, except it seems to me to be more sort of related to actually sort of putting your models into production. So it seems to be quite focused on sort of, running sort of from the command line instead of running Jupyter notebooks. So it's quite based on, I'm not sure if you know, like YAML files, which are basically just like sort of XML type sort of files or whatever to give you all the parameters for your model, and you specify like a set of parameters like how many epochs you want to run, what sort of type of training you want to do, what type of model you want to do, and then just like feed that into the Catalyst sort of front end that sort of sits on top of PyTorch. So within the Catalyst website, there's like a link to somebody that had used Catalyst for the steel defect competition. So I was like looking at their solution, and so I've just started running with that. A lot of people as well, it seemed like a lot of the people who did well in the competition, as well as just doing purely segmentation, they use a classifier in front of it. So like that's what this person does. They actually train 3 different classifiers, and then they use like an ensembling technique, basically to get rid of any of the images that don't have defects on them. And so like they sort of chop out half the images just to leave the ones that have defects, and then they stick those through the segmentation process. And again, then they use 3 different types of segmentation models. So one of them's a UNet, one of them's the thing you were talking about last week, whatever it is, the pyramid network thing. And then they've got like
keep going.
Yeah, then they've got a third one, which is some PSP net. I don't actually know what that is. So obviously like each one of these takes your standard sort of 6 to 8 hours to train. So because of the fact that like Catalyst is sort of very command based or whatever, I've had to like rejig things a lot to get it to run their thing within Jupyter notebooks so as I can use Google Colab. So with that, I've managed to like run 1 classifier and 1 UNet segmenter or whatever. And so I just managed to sort of submit my first result this morning. So I got a 0.897. So I'm very close to breaking the 0.9 barrier, but still not there yet. But
you're now the leader. Is 0.897 private?
Oh, sorry, that's public, and 0.890 private. So getting closer, but as I say, so like that, there's just 1 classifier and 1 segmentation model, whereas like the person themselves has 3 and ensembles between them. So I think I should be able to break the 0.9 barrier once I've trained those ones as well. But Catalyst looks very good. It's like a lot of stuff in there. It's pretty much like all of the stuff that's in FastAI is in there, and a lot more besides, I think because of the fact that it is sort of like maybe at a lower level than like FastAI in some ways. It is good for sort of tinkering and doing experiments and stuff. The thing I haven't really seen with Catalyst is I haven't really seen if it's got sort of much stuff for actually sort of analyzing your results to see what images you have and to see what's done well or whatever. Certainly, like in the person's notebooks that I've been copying, there's like no sort of images output at all to show what you've achieved or whatever it is. Just put the data in and get the results out. So, but I've only had a few days to play with it, so there's maybe more stuff in there that I haven't seen.
Cool. That's very cool.
The other
new
problem
library.
I've had as well, Catalyst seems to be changing pretty quickly. And yeah, like I had like a lot of problems as well where like the person that's done the steel defect Catalyst notebooks or whatever, it seems to have been using a different version of Catalyst. So I had to like tinker with it quite a bit to get it to run with the latest version of Catalyst. So that's something to be aware of if you do like try and take any of the steel defect stuff that, the newer versions maybe a bit different that you have to play with it a bit. But
yeah, if you could post a link to whatever you were able to do, that'd be great.
Yeah, sure. Yep.
Is the older version mentioned in the notebook that you're looking at, Steve?
No, unfortunately, it's not. It's like basically, like he just includes Catalyst, and he must have just included whatever version was the version at the time. Right. So he doesn't have a hard code. So that threw me out a bit because it meant I couldn't just sort of go and run his code.
Okay.
But so that's what I've been up to this week, just getting up to speed with that.
Oh, cool. That seems like a interesting program, especially from I guess, as you pointed out, production and lower level and different, but I guess still, so you said it's still evolving rapidly now, or it has evolved rapidly from when the guy used it to where now it's very different?
I think it's still evolving pretty rapidly. Like they've had, looks to be about 4 different versions over the last year or whatever. So I think they're stabilizing a lot, but it's like quite a few libraries where they let people put sort of experimental code in, and like it goes off into one branch. And like it was like being referenced by sort of different namespaces and stuff, and like now those bits and pieces or whatever, I think they've been sort of accepted into the main branch, and so they're part of the core functionality now. Whereas like when he was using it, they were still in a sort of experimental thing. So just sort of the namespaces for different bits are changed. But it seems to be, like all of the stuff that you were saying about last week, the pyramid networks and things, as new papers come out, they seem to let people sort of add those into the code, but as an experimental form, and then when they sort of become stable, then they get put into the core functionality.
Cool. Which it's very interesting. Were you able, or last time you had spoke, and I wanted to kind of double check with you. You'd mentioned that you saw, if I recall correctly, that you saw better results with Imagenet stats. Is my recollection correct, or did you say something different?
No, that's right. Yes, sorry, I saw your post on Slack, but I hadn't got around to replying to it. So like basically what I'd done previously was create my own tiles using the guy's tiling code. And like part of that is it generates stats when you make your tiles. And the stats that I was getting were like quite different from what the guy had. Like I was getting 0.3 or something as the mean on them, whereas he was getting 0.5, I think it is he gets or something. So yeah, like what I tried doing was first of all, I was like training with my own stats, and then submitted that. And yeah, like even though like my sort of images were sort of similar to his or whatever, I was like having 7 tiles per image, whereas he's got his 6. But the results I was getting weren't very good. So I thought, well, because the stats are quite different, I'll try his stats. So I tried them and got like an improvement. And then I thought, well, because of the fact like the first stage of the unit is using like Imagenet stats, so I'll try that. So I tried that and got better results again. what I did notice was, though, that was only on the training process. So obviously, like then on the inference notebook, it also like uses stats, and I'd actually left the stats as his stats, and when I tried to change the inference onto Imagenet stats, then the results got slightly worse. So
in fact, it's interesting you bring that up, because that was going to be my next question based on my experience. I saw that same thing, and I used the same Imagenet stats in both places and got slightly lower results.
Right. Yeah, so I got better results when I used it in the training notebook and slightly worse when I used it in the inference notebook. But I suppose the real test, I would probably have to like test it again and use his proper notebooks, use his tiles and his notebooks or whatever to see. Whereas, yeah, like I was using it with tiles I generated myself.
How
But
much did
certainly,
your stats vary from the Imagenet stats? Any idea? Like, do you recollect? Is there like a big difference?
I can tell you, Rekil, at least for mine, because I think, at least from what Steve said, I computed the Imagenet stats, and even though I'm using kind of similar code, but I'd done small changes. So mine were exactly what Steve said. I think 0.3 something, and for each of the channels, 0.3, 0.3, 0.3, but with second or third decimal varying.
Okay.
For the mean. And in the Imagenet stats, which I applied in the last or this past week, my recollection is the per channel mean is somewhere in the 0.4 XX.
Okay.
0.48 and 0.45 and 0.4.
Sorry, Mehul, were you saying something? You're very faint.
Oh, sorry. Is this better?
Yeah, slightly, but still.
Yeah, still faint.
I don't know. How about now?
Yes, better.
Yeah, Imagenet is like 0.8, 0.485, 0.456, and 0.4406.
Yeah, and my stats, if I can look it up really quick in anything that I have.
And Srinivas, were you saying you were getting better with Imagenet, or were you getting
No, slightly worse.
with Imagenet?
Yeah,
Okay.
with Imagenet, but with the clarification, which gives me an idea, but I can't explain it, which is that I was using, as Steve just pointed out, you use the stats both in the training and
Right.
in the inference, and I was using the same stats in both places. So when I use Imagenet, both places, then it got slightly worse. Like I mentioned in the post, it was 0.88. So in the third decimal, it was less, but therefore about the same, but slightly less for sure, because both the public and the private was slightly less. Calculating my own stats, which I think, is approximately what Steve got from what he said, a 0.3xx, and applying that both for training and inference, I got slightly better results, meaning 0.884 versus 881 and 888, closer to 8.9, I think, in one of the private or public, I forget which, but something like that. Whereas, it was slightly different.
Right. Okay.
I can share the results in a minute.
Okay. So just to clarify, so you're getting better results when you used the data sets stats both for training as well as test time, right?
Yes.
Okay. Okay. Yeah.
And my computed
right. Yeah. Exactly.
stats.
Okay.
But what Steve, and that was going to be my question, because Steve had seen better results, but as he just explained, he saw better results when he used Imagenet stats in training, but then, left and I was wondering whether to do that, but it didn't, and maybe we can discuss it here, but I didn't quite, other than just trying stuff,
Right. Exactly.
I couldn't figure out a good reason why to do it.
This one, like, again, going back to like how Bengali AI also, since the data set is very different from what Imagenet is, computing stats there, that was the only reasoning I had, if it makes sense. to compute your own stats instead of using like the Imagenet stats, which again like makes sense in the sense like goes against the whole thing that you've trained it on a completely different thing and you're fine tuning it on something different.
Yes, but isn't it also the case that here you have so many images that you could potentially, if since you're unfreezing and training, that you are giving it, of course, you're only training it for 20 epochs, whereas
right,
who
exactly.
knows how many epochs Imagenet is trained.
Exactly. Yeah, I mean, like that's what. So that kind of gets hairy again. Like, and then how we unfreeze is so much more different. We start from random weights on one side. You're starting from pre-trained weight. But that was kind of my idea. Like, maybe because the data set is so different, it maybe makes sense.
Right. But then I was more also focused on the question of, does it make any sense to train with Imagenet stats and then infer using the computed stats?
Yeah, I can't, at least I can't think of a reason why that would make more sense.
Yeah, but that seems from what Steve was saying, and I haven't yet confirmed, but that seemed to yield Steve the best results.
Mm-hmm. Right.
Yeah, that is what gave me the best results. But yeah, it was just like an accident that it happened. It's just
yeah, but I was hoping you had made that accident, because when I did it, I was like, I hope he didn't change this, because that'd be interesting to know the answer. So I'm glad you made that accidental non-change, because it gives the answer which says it's better, but then now we can't come up with an answer of why.
Yeah, I guess it's one more of those things like you just try when you're submitting.
Yeah, that's what is the empirical nature of this stuff.
Yeah, empirically, like you would never do something like this, right? Computing your own stats and trying to use something else, some of the weights.
Yeah, the only thing I was thinking of is, training, obviously, as Steve just explained, and you did too, is it's gone through, and given the encoder is the ResNet, that it makes sense to use that. All the test images are actually only of the, your current data set. So I was wondering whether that makes sense that you would use the computed stats for inference, because you are using the test data set, which is mainly the images, that are there in the data set. Whereas for training, especially given it's UNet and it's the ResNet on the encoder side, you're better off using, the Imagenet stats, and therefore the thing that Steve stumbled on is actually the better approach.
But isn't that the case always then? Like, I mean, anytime you're basically not training for 1,000 classes of Imagenet, we should be kind of using this approach, right?
Yeah, that's
transfer
a good
learning
point.
sort of a thing. So I don't know.
That's
this is
not what is
very
recommended.
intriguing. Yeah, exactly. So yeah, this is interesting results.
One thing to note is, like, when I say things got better, they only got better very, very slightly. It's like sort of at the third decimal place they were getting better in the submissions. So it's not as if it was giving like a massive boost or anything, or a massive performance fall or whatever when I changed back. So
yeah, that is a good point, because I saw even the Imagenet to non-Imagenet is only different, as I mentioned, in the third or the second decimal place at most. Interesting. Which leads me to next. Anything else, Steve?
No, that's it. As I say, yeah, it's just sort of completely switching libraries. So I'll see how I can get on with that. But there seem to be like a lot of the solutions that were in your document last week use Catalyst. So I think it is quite a good thing to go ahead with.
Okay, that's interesting. I'll have to play with it then. Which leads me to this question for Rachel. Maybe you looked at it, because I remember you making a comment in one of our early meetings. Is feature pyramid network different, Rachel, from what you know from the UNet, or is it this? I remember in the lecture, Jeremy kind of said, oh, you have to come up with fancy names. So they came up with a fancy name. Look, it's just a fancy name for UNet. So I didn't really look into it. But now, given that multiple people are using it and getting good results, I was just curious whether, I remember you mentioning something. So I was wondering whether you had looked into it any closer.
I also, looked into it after Jeremy mentioned that, and I think it looked very similar to what the UNet does. But I do remember there was a slight difference, which I don't know what it was right now.
Okay. I mean, I just marked it as to ask you because you had made the comment previously that, yeah, it is very similar, and Jeremy echoed the same thing. So I never bothered to look at it. But then now some people use that and ensembled it with the unit. And I was like, why would you do that if they are both almost the same? Because you would,
Yeah,
much
true.
rather do it if
Good
it's
point.
different.
Yeah. I don't know if that's a bigger network though. I am not sure about that. Like the unit just goes like a single U, so you just encode and decode. Whereas at the feature pyramid, you encode, and then I don't know if you have like there are like multiple decodings, like branches.
Huh.
I'm trying to look at the diagram and I can't remember what I had made note of, and yeah. I can see and probably clarify something next time.
Okay, yeah, that's great. I just was wondering because that seemed to be something that people had used, and I was like, well, it's both they may dismissed it, and you had remarked it's very similar. So I was kind of a little bit surprised. So I just wanted the opportunity to get it clear in our heads of what it is and what it's not.
Yep. Yeah.
Anything, Rachel, were you able to?
No, I have, a very unproductive week. So yeah, I missed last time, so I have to catch up on that session also. Thanks for putting
Yeah, I
the
just
recording.
posted a bunch of, finally said, okay, we need a fresh set of ideas, and I posted a doc. Let me know if access. I thought it granted access, but then I saw Joseph and Steve requested access, so I'm confused whether it doesn't automatically give you even view access.
Let me check.
Yeah, when I first tried to get it, it was said you'd have to give me permission.
Oh yeah, for me also it says request access.
Oh, okay. So I'll add you and Mehul and anybody else because it's really weird because I thought anybody could view and they could just not edit. But okay, I'll fix that right after. Mehul, anything you'd like to add?
Can you hear me better? Or...
You're faint again.
Yeah.
Faint again. What's going on? How about now? No.
Yes, much better.
Much better. Yeah, I don't have a productive week either. I had a question about the FPN. I'm surprised.
You've gone faint again.
Oh. How about now?
Yes, better. Don't move.
Don't move. I'm almost inside my laptop.
Swallow the mic.
What's going on? I don't know. I need to go and watch that lecture about where Jeremy compares the feature pyramid network to UNet, because that feature pyramid network came out of a very famous paper, and the goal there was object detection.
Right.
So you are putting a box around things.
Right.
And so it's a key part in
object detection.
Yeah, exactly. Like faster
different scales are needed. Right. Yeah, exactly.
Yeah. Although, so I just need to go back and check why that is so similar to UNet.
Yeah, he doesn't discuss feature pyramid at all. He just kind of like totally, in classic Jeremy style, it's like, this is an example of how you make up stuff just to impress people, and it's the same thing. And if you didn't know about that it existed before, you kind of make your stuff and publish it in journals. And so we'll not do that. We'll just get into UNet, and that's all it says.
I mean, if you look at the diagram, it's literally like an inverted U, right? That's the way they draw. If you look at the paper also, the feature pyramid network is just upside down U. And the UNet, they draw it the other way around.
Yeah. That was the other thing which was somewhat confusing when I looked at the paper. It's kind of like you have to invert what you understood in UNet to correspond.
But yeah, as far as I remember, there was, I really don't remember any main difference like that.
Take the time.
Yeah, we can look at that next time. Yeah.
The code I'm using has like another type in there. It's called a PSP network.
Yeah, I've seen that.
What is it, Steve?
It's called a PSP net.
PSP.
I don't even know what it is, but yeah, they use 3 different types of segmentation models. They use UNet, the pyramid one, and a PSP.
Yeah, this is
But
also
I don't even know what that stands for.
That first P is pyramid again, pyramid sense parsing.
Oh, right. Is it different from the FPN then?
I have to look at the image to remember what it.
Right.
It's so hard. You make these notes and then you don't know where these notes are. I try stuffing everything into Google Docs so I can do a Command F, but then that also doesn't work.
Yeah, I have it all in hard physical notebooks since I like
Oh,
to
that's impossible.
write, and that becomes a search
Yeah.
for all the minutes.
Yeah, so maybe I'll take it up on myself to kind of at least give us a brief gist of what PSP and FPN is next session, so that I have some responsibility to cover this week.
That'd be cool, because
that'd be great.
I'm just turning them on and using them. I've no idea what I'm using or whatever, so I just
Cool, yeah.
switch them on.
Sounds good. Yeah.
Yeah, that'd be great. Just like we did the UNet and the hypercolumns, it would be good to
If you guys
understand.
can share some working code that you have, so then when I'm trying to like bridge the diagram with what the code is doing, so then you guys will also be familiar. And I have to anyway start from scratch for code. So if that makes sense, yeah, it'll be helpful if you can share something. Are you using Catalyst, right? So maybe I can use the Catalyst code itself for FPN and PSP.
Yeah, as I said, I had to like change the guy's code in quite a few places just to get it to work with the latest Catalyst. So
even the architecture?
Oh no, I haven't changed the architecture.
Okay,
I just
right.
mean like sort of some like goals or whatever. But yeah, I can maybe sort of share my GitHub link or whatever with the modifications I've made.
Yep, sounds good.
So you don't have to go through it all.
Right. Yeah. Perfect. Yeah. That sounds like a good plan.
Okay.
That'd be great if you can look into it and give us a quick rundown of differences or unique features.
Yeah, what is happening in both,
Yeah, I'd also, I think, try to publicly sign up for at least looking at maybe one, if I'm aggressive, there may be 1 or 2 of the things to learn or try that I posted from the doc last week. So I'll just go to the doc and share my screen, and just so Raquel doesn't feel picked on, you'll see how many tabs I have open as well and multiple windows.
I'm sure you can't compete.
Yeah, I can cook an egg on my laptop on the other side. It's becoming too hot now.
Can you see my...
Yep.
Yeah, that's half the number of tabs.
I for display, I use a Sony TV. I hijacked my Sony TV from it, so it's a much larger screen.
Before we get into the doc, so I just wanted, can you see my submissions screen?
Yep.
Okay, so 2 things I did last week, pretty pathetic. Didn't do a lot of good work. I was disappointed. But you can see the Imagenet stats is private and public scores, like 882 and 887. And if I scroll down, you see the original submit to, which is actually my cross entropy, no self attention, just a dynamic unit. And you see 0.884 and 0.890. Versus, and that's using my own stats for the images, both in training and in inference. And then if I go way up, then the Imagenet stats are these, and you can see they're just a teeny bit lower.
So your simpler model actually is giving you better results.
Yeah.
Right. Okay.
Yeah, and also it's kind of the second time in a row, because this happened to me even in Human Protein Atlas. My very first run gave me the best results, and no matter what I tried after that, I never got up to that, which is pretty disappointing. in terms of error analysis. It's like your error analysis is pathetic. But you can see that none of my subsequent scores have exceeded my very first simple, no self-attention, just a dynamic unit from FastAI, and just the standard cross-entropy loss.
Were those like the default FastAI augmentations? Or did you
Did
change
I
something?
even use? No, in fact, not even all. Just horizontal flips.
Oh,
Maybe
so
vertical flips. I'll look at it, but I
So
know
did you-
for sure horizontal flips.
no, did you go in and change this, or because FastAI does a bunch of lighting and all that kind of stuff?
Yeah,
switch
but it's since I mostly reuse the guy's code. He just uses
Okay, cool. Okay.
the horizontal flip part, and I want to change it now as part of the enhancement, but I just let it be. I didn't change, add, or subtract from what he did, and if I recall, and I'll confirm that offline, but my recollection is it is just the horizontal flip.
Okay.
Oh, is that the guy's notebook with the tiles?
Yes.
Yeah, so he does his own, he does 3 types of augmentation, doesn't he? But yeah, he wasn't even using the FastAI stuff because he said FastAI loads all of the code into memory and he was running out of memory, and so he was using his own augmentations. So yeah, it's not using the default FastAI set.
Okay, cool. Okay.
Yeah, I know for a fact he used horizontal. He might have used 1 or 2 more.
Okay, cool.
And then the other thing I did, which was interesting, was the top result that I had is I tried to combine losses. So this loss, I just made up the name focal dice, is 80% focal loss and 20% dice loss. And as you see, it kind of...
1 second, before we kind of leave this up, I just wanted to ask you a quick question, like how many epochs are you training for? And is that being consistent, or are you changing that across your experiment?
Yeah, I'm doing 19 epochs, 4 epochs frozen. So you just train the top 2 layers, I think it is. And then 15 for the entire, all of the network.
And is that
I've kept that the same for everything.
Okay, and is that what the which one notebook you're following? He also used like 20 epochs, because that is something very, very confusing for me. Like I don't know, like whenever I see a notebook, like a winning notebook, they seem to be using like 50, 60, 70, 80 epochs.
Oh yeah, yeah.
So that's why I'm wondering, like, how much of a difference is that playing?
Oh, I believe it does make a difference. In fact, my goal at some point is to just let the basic thing run for like, double. So if I'm doing 20 right now, to let it run for 40. And I think, and Steve can also confirm this, if he's able to run, I think I'll get to 0.9 is my belief, but I could be proven wrong. But because to your point, yes, almost all the winners run a significant number of epochs.
The code I'm using at the minute, it runs for 40 epochs on each thing, but it's also got like the callback to save your best epoch. But it actually, like the one I was running, it was like saving the best epoch at like epoch 16, even though it was running for 40s. It was a bit of a waste of time, but yeah. Previously, I'd tried to keep the epochs always constant, so I was getting a sort of better comparison of the results. But yeah, like now I'm moving up to more epochs.
Yeah, that's a good point, Steve. I should make a note to myself to, I think through callbacks, if you can pick the model that gives you the best metrics, the reason that what you just said resonates also is the fact that in my doc, and we'll get to that in a minute, there was somebody who had mentioned that it actually helps to train for a certain period of time, and like you did maybe run 2025, but if 16 is your 16th epoch is where you get the best metric, then take that and then train with a different loss for some period of time. Use that model and train with a different loss, and that seemed to that person seemed to say that that is a good approach to get to the best results that he saw.
Right. I think like especially like the low as loss where they suggest you use cross entropy first, and then yeah, makes sense. Yeah.
Exactly. So that is why, I mean, that's the next thing I want to try, because I mean, this was just a step along the way that I just combined focal and dice loss to, like I said, with 80% focal loss and 20% dice loss, just kicks. Those were the two that I, right, the code handy and I could just use that. But what I really want to try is what I just mentioned, which is run with either focal or binary cross entropy, because those have given me the best results so far, and identify through the callbacks the particular epoch or the model that gives the best metric, and then take that model and then, exactly as Rekul said, try lowest loss reduction for a certain number of epochs and see whether that gets me past the 0.90 barrier. And so switching, can you see the document now?
Yep.
Yep.
Yeah, so I think here, a couple of things I'd like at least. So I think Rekul, as he mentioned, would look up FPN, and maybe another one that we talked about. And, I definitely would also like to understand, and I'll see whether I can spend some time on it and give a short, brief update if I'm able to understand this bi-tempered logistic loss for dealing with noisy data. And anybody else, if they want to care to pick up any of the topics here and give a quick update and or trying it with the competition, that would be great. The other thing that because a number of people mentioned it, and so it'll be worth trying and or picking to see what it is about and what and how it helps, is these pseudo labels.
Yeah, right.
A lot of people seem to apply that technique to get better results, and I haven't looked at it to see what the.
It's pretty straightforward. I used it for the last competition that I took part in. It's
what is it? Sorry?
So it's pseudo labeling. So you're fake labeling your data. So you have only that much of data that is labeled, but you have a lot more unlabeled data, right? So you can run. So let us say you have 1,000 images, and you split that into, 1,000 images that have labels, 200 images that don't have labels, which is your test set. So you train your network on these 1,000 images. Once you're done, you put in your 200 images, which is from the test set. You predict the labels for that. So now all of a sudden, instead of just 1,000, you have 1,200 with labels, right? And then you retrain your whole network again from there. Now, there are nuances in that. Is like when you make a prediction, you're obviously not going to make everything correct. So you can threshold and use only those predictions, let's say, for example, which are more than 90% accurate or more than 85% accurate that you want to trust with and go. So It's kind of like artificially simulating more of your labeled data sort of a thing.
Okay.
So that's what kind of pseudo labeling does.
So when you tried this, did it work for you?
I haven't tried it on this one. I tried it on, I think, the plant stuff. And for me, I got very similar results, but I ran out of patience. It took forever to train and I couldn't wait. But I had it implemented. So I was like, oh, okay, that's good enough for now. So yeah, I haven't tried it on this.
Is that then, I'm curious as to how, is it something like, I guess it's not something like label smoothing, because that is just on the training set.
Right, yeah. And I agree with what you said. Like a lot of people have seen bumps, and not just in this competition, but a varying number of competitions. Like,
yeah, that's why I really wanted to get an idea, because so many people who were in the top have alluded to it. So at least I wanted to kind of get an idea of what it is and how to implement it.
So I think you guys already have it, right? Because you're already making predictions. All you have to do is take your predictions, and which will be, I don't know, I think, are you predicting that as images, or are you predicting that directly as like RLEs?
No, we predict, I think we predict, I have to look at the intermediate step to see whether we predict the image, but it's obviously the unit will only predict the image, right? And then we translate to RLE, I believe.
Right, so that's what, so all you need is that step. If you can just save those that you have predicted. Now, you can, first step would be just directly use all those images back into training and then retrain your network. And then that would be, I think, just to see if everything works right. And then the next step would be like, before you save every output for every pixel, you just save based on maybe, I don't know, like some metric, like if it is greater than this, then you believe like it is right, and then save it. Again, there also I've read where people don't care about where to threshold. Without thresholding, just saving everything seems to work. So again, those are some are
variation.
Yeah, exactly.
But that's interesting.
It seems like a very cool idea, and seems like it should work every time. But yeah.
Yeah, again, it's one of these where until you try and for a particular problem,
right, exactly.
I've seen it's an empirical thing. It may, I mean, Loess laws or even focal loss is supposed to be definitely better, but for me,
yeah, but I think Loess laws is so tricky because the paper itself says like there are so many hyperparameters that seem to work. So again, like you run out of patience at some point. Like,
yeah.
Should it be just more epochs, or should it just be like different hyperparameter tunings, or what it is?
Yeah, which is why this is, increasing. It's not yet an exact science, right? Meaning it's
so much more empirical before it's actually
empirical
science,
things.
Just to go, one more thing, like, do you want to do anyone else up for doing things in pairs rather than doing it singly? If anyone else wants to look at the network, or I'm fine, like if both of us can kind of look at whatever you were suggesting, Srinivas, so at least we'll have like two pairs of eyes looking at the same thing, so we can at least.
Yeah, sure.
Okay.
Just drop a note. I was just saying the pseudo labels and the bi-tempered are just, because I just picked a couple. I mean, at least I'm somewhat familiar with mix-up and label smoothing. Not that I've implemented it, but it's kind of there, and I have the understanding of the concept, but these two things are totally new. So I wanted to understand what they are and then potentially implement if I can get there. But
right, yeah, mix-up and cut mix actually with a bunch of other people, we actually did that and like pushed it to fast AI. So that is really simple. So we can actually go through that at some point. But just that next week, even if we try to recap one of these things, I don't think we'll be able to do more than one or two of them, right?
Yeah, exactly.
So
I agree. But it's just that this is the long list that we...
Yeah, I would love to go through all of it, yeah, for sure.
That I shared and then made up based on, all the details in this. And I didn't even go through all of them in the link. I just, went through enough to where, as you said, I was like, okay, I'm done.
Right.
So, sorry, anybody else? I'll stop sharing. Anybody else on the call want to comment or chime in? Joseph or Alvaro?
No, I got to get myself up to speed before I'd want to comment.
Yeah, and post any questions, Joseph. It took me, Steve was the one to get it all the way to submission, and you have to kind of go through multiple steps in this competition, because it is a kernel competition. So, and it has limits that it only needs to run less than an hour. So you need to kind of go through multiple notebook flavors or versions that you just write out, and then another notebook which just reads and submits and stuff. So if you run into issues with that, just post on Slack, and since I've gone through it, I'll try and help.
Okay, that's great. So I'll be standing on the shoulders of giants. So,
more like chauffeurs, as I explained in a different context.
So Srinivas, is there any follow-up on the on the move to discourse? I think you're going to move this group to discourse, right?
Yes, I did mention it last time, and to the team, and I think it'll be good because as we just went through on the, I had posted all of the attention links, and now I have to go. Fortunately, I saved them, but it's the same problem, right? Instead of just say refer to this, you have to go dig it up. And what TWIML staff said is I think they'll have like a rev of discourse ready maybe in a week or so, and then we should be able to get there with this group.
I can't wait. That'll be terrific. I can't get off of Slack too soon. So.
Anybody else? Any other thoughts or inputs or things we should try? So to your point, Rekha, was there anything different in the LOAS laws that you saw other than what I'm mentioning? Because in one of the, if you dig into the rest of the document, and I'll open it up to others as well. I didn't know even to view it, you had to have permission, but it just said that, in fact, I can probably go to that point where somebody says, yeah, here you see 0.75 binary cross entropy and then well, I'm not sharing, am I? Sorry.
Yeah, Srinivas Alvaro here, and I'm way behind Joseph even so, but I will try to get back to this group as possible.
Sounds good, Alvaro. And like I said, if you have any issues, let us know and we'll chime in and helps. I think, I wouldn't have gotten where I got to without Steve blazing the trail first. So we all help each other.
One of the other annoying things with this competition is the fact that they've changed the submission files from the original competition. And so like if you actually go and take any of the notebooks that are on the competition, they're slightly different because they changed the format of their training CSV file and they changed the format of the submission CSV. So you just need to be aware that if you take any of the notebooks that are on the competition, you need to change them slightly to change the format. So yeah, you can get like code off us or whatever to fix that.
Yeah, excellent point. I think that's a very good point too. Yeah, we did it so far back that forgot. So thanks, Steve. Yes.
Yeah, it was just because I'd started using the Catalyst stuff this week, and then I found like all the notebook, so all the CSV files were wrong again. So
yeah. So in fact, the library is used. You can see here, but somewhere in one of these places, the guy explicitly says that the best way is to train the model using binary cross entropy laws or cross entropy laws, and then picking out the best metric and then model with the best metric and then training with the LOAS laws.
Right, I think that comes from the paper also. So the GitHub link also, they suggest that you go first BCE and then move over to LOAS laws.
Okay.
So more like.
And one more thing I thought which was very interesting and along the lines of what you were doing, Rekha, or trying to do, which this competition and the previous one convinces me that if somebody can solve that problem in general, which definitely makes a big difference, is trying to reduce the problem set to where you can iterate. And as Steve was mentioning, and I've also encountered, I mean, it's just, it takes so long otherwise, any of these empirical experiments, that I think that's a very worthwhile effort to try and get it to where it can be turned around very quickly, any experiment that you run.
Right. I think this was the main thing. Like the first time, my first question on this Kaggle group was, how do you build a good validation set, which kind of triggers off, how do you kind of get a representative like subset problem? And I really don't know. I have looked around so much for it. Everyone says like hand wavy stuff, or I don't know if people want to reveal what the secrets are, or the answer is, yeah, like use bigger GPUs.
Yeah, that's where yeah, and we stopped. In fact, just we exactly in the Human Protein Atlas, we agreed to stop when we reached the point where okay, it's just more compute and you'll get better answers. Because at that point, I mean, we are not learning or doing anything substantial. I think that's where, for example, Jeremy's attempts at Imagenet and those kind of things. You realize the value of that much more by going through this exercises. Right. Which brings me to one point here that the guy hasn't said too much about how he, about this particular thing, but this competition also gave a prize for the most efficient solution. And that's a kind of an interesting twist.
I mean, I guess they wanted to put it into implementation, so then you can't be ensembling stuff forever to get it
or very complicated thing. And you can see that again, he does, added dice loss as a component and continue training on the checkpoint from stage 1. So he kind of like does it in stages, and then also use you see the 3 components. So, and as Steve was saying earlier, classification loss, and then the segmentation loss, and then on top of that, the dice loss. So he might be doing, what Steve was saying of first classify, get a limited set where the errors are, and then do the segmentation, and do the segmentation also in multiple kind of steps.
Yeah, like all the winners seem to apply classification to get rid of the images that don't have any defects. I was actually wondering, because of the fact that the segmentation, the front end of the segmentation uses like a ResNet or something, is it possible to reuse the ResNet that you've trained for classification as the front end of your UNet, or do you always need to train the two separately?
I mean, they're doing different tasks though, right? So you're saying you just want to remove the classification head sort of thing?
Yeah.
But then, I mean, all you're doing is using the same ResNet, which already has like your pre-trained weights, I guess, right?
Yeah, but like in the UNet, you're starting off with like a basic ResNet or whatever, and then you're training on your steel images,
right?
To get the segmentation. Whereas you're doing
so when you back propagate over there, your losses are like calculating for segmentation labels, right? Whereas if you wanted to do it for classification, your labels are going to be just, is there a defect? Is there no defect? So that they're kind of back propagating 2 different kind of losses, essentially, right? At least that's what I understand.
Yeah, I was wondering, was there any advantage to taking the ResNet that you trained for the classification problem and using that as the starting point for your UNet because of the fact it already seen this type of image? Like, as you say, like one's for classification and one's for segmentation, but at the same time, a normal ResNet's like trained on bicycles and cars and things. And whereas like if you take the one for your classifier, at least it has seen this type of image.
Yeah, that's a good point. Yeah, I'm not sure.
Yeah.
Actually, I wanted to ask one more question between us. Like, has anyone tried, I think, Srinivas, you were talking of trying out transfer learning. That is one more nice thing of kind of reducing your data set, is like reducing your image size, right? So
could you repeat?
No, sorry. I was talking, can you hear me now?
Yes.
Yeah.
Okay. So I was saying, you were talking of trying out transfer learning, and I was saying like, that is like kind of artificially like reducing your image size where you use smaller image sizes. So did you try that out, or have you been trying like full size images itself?
Oh no, it is all transfer.
Do you mean progressive resize?
I'm sorry, progressive resize. Yeah, sorry. Yeah.
Oh,
right.
progressive resize. No,
Yeah.
that I did not do. It infers to the full size. And actually, they do say that progressive resizing gives you better results. In fact,
Okay.
the other thing, last time I commented on it too, Rekha, is what is fascinating. If you go down, you can see my, so if I think, where is that? Oh, right here on item 9, progressive crop sizing versus training on crops versus training on full size, and then random crop. And
okay.
what was interesting to me was consistently I saw that training on full size was obviously much more time consuming, but gave better results than training on crops.
True. Yeah, that makes sense. Yeah.
Right. And then this random crop I threw there just because I
Actually,
wanted to understand, because it was puzzling to me that they got good results using random crop when the errors could kind of go across crops and stuff. So
right.
I just threw it in there because I wanted to understand how in the world they are using something like a random crop in this kind of competition.
Actually, going back, like, I don't think always full size is going to help, because I think I've read across like a couple of competitions where, because of transfer learning, the more you kind of move away from your pre-trained image size, the more you're moving off. So there have been, like, I think, I can't remember exactly which competition, but they specifically said that not training on the full size image kind of helped. I forgot what size again. That's the other question which I have. Like, when you try, what size do you start with? Does 32 by 32 translate well? 64 by 64 or 128? Where do you kind of start ballparking your image size from?
Yeah, and if any one of these bullet points that I've numbered, there's much more detail below in the same doc where I cut and pasted, and obviously much more because, as I said, I didn't look at all of the links. So there's I just chose 40 and then I moved to the top 10, but there is between 40 and 10, there are a whole bunch of other things that
Cool. Okay.
have explanation too. But for each of these 15 or 20 points that I pulled out, there is details in each of the wherever those techniques have been used by people and submissions.
Cool. Yeah, sounds good. Yeah, we'll look at that.
And the other one, which I thought just very interesting and we be done, was this thresholding, which to a certain extent it's the same as what Steve was saying if you classify, but also slightly different because I wanted to understand what this triple thresholding means, and also the difference between where they threshold on the labels and then the pixel. I mean, I'm familiar with the pixel threshold, which is basically says unless you get, more than this number of pixels, don't even classify because of the F1 score, the false positive are penalized, as we have discussed before. So that I get, but the other two, the label thresholding and the triple thresholding, I wanted to understand. Even label thresholding, I understand a little bit because basically what it said, if I recall correctly, and people can go through it and correct me in future discussions, is I think it says, it kind of goes to the classification thing that Steve talked about, because it just says that, if I have very less number of these labels, then I'm not even going, then I'm not predicting that label unless my confidence is high for that label, because I know that, that label is present less often, or something to that effect. But that's where I wanted to understand the triple and label threshold more as well.
I haven't heard of the. What is the triple and the triple thresholding?
Let's see. It's talked about. I think in the best. Let's see. There's a simple. Because that's, if I recollect correctly, it's something that was used in the TSD, in the winning entry to the TSD salt difference
Oh, okay.
thingy, and then that guy,
Yeah, cool. If it's in the doc, yeah, I'll look it up and then we can discuss probably next time.
Yeah, that guy then talks about it and then points to, obviously the link that, so here is pseudo label and then is it in this, now can't quickly find it, but yeah, I do know that it was mentioned as one of the, there's a paragraph on it, I could just search, I guess. Yeah, use triple thresholding and triple thresholding explained here.
Okay.
So there's a link.
Cool. Okay, I'll look at that.
So that's something I wanted to understand better as well. So I guess we'll wade through it bit by bit to get smarter about any of these things.
Yep.
Okay, cool.